Good morning, my dear students. I'm going to solve some of the exercises we tried to solve yesterday. So decided to record some videos so I can explain in a better way one by one. So you could take your notes and stuff like that. Okay, let's get started for this exercise. As you can see, how many grams of this you are comparing to very important compounds before getting started to solve the exercise. Definitely, since you're receiving for this exercise double data, you're supposed to underline the two of them and something like that. But before doing so, you also are supposed to have the chemical reaction. So first of all, let's get to work on that part. Let's solve the first part. Let's construct the chemical reaction. You're supposed to have, in this case, nitrogen, right? Plus, it says hydrogen, definitely, and that's going to give you specifically NH3. And also that you will need to have the balanced this reaction. So have it balanced in the first place. So you're going to add in here, if you put the 3 there, right, then you're going to be set up ready. And also if you put a 2 there, it will be, so 2 times 3 is 6, 2 nitrogens to nitrogen. So basically it will be done. Then once you have that, before getting started to solve the exercise, you need to know what is the limiting reactant. That's one of the most important steps. Since you're receiving the double data, please enclose the double data you're receiving in this part. You're receiving this one, right? You're receiving this, and you're receiving this. And I'm going to copy in the upper part some of the grams I gave you, because it says you received 15 grams, right? These 15 grams, I gave you 15 grams of this one. I'm going to use another color so you can see it in a better way. I'm going to use maybe, yeah, this color. I gave you 15 grams of that one. And also I gave you 15 grams of the other compound, right? It's like the same mass for each one. And then you must analyze which is the two masses and stuff. So you have to compare the two of them before getting started to solve or answer any questions on what is the product you're going to obtain. So first of all, you need to find what is the limiting reactant. How are you going to do so? Because this reaction is going to be, since it's balanced, you can read the reaction in terms per grams. I repeat, you can read this reaction in terms for grams. So read it in terms per grams. How are you going to do so? Because you have in the first one, which is nitrogen, right? Nitrogen, it says N2. So you have two nitrogen. So then the mass in this specific reaction is going to be 28 grams, right? I want to use another color for that one so you can see it. Let's use another color for saying that's the mass actually from the reaction. And I'm going to use the same color, that is copy there. 28 grams of nitrogen, right? It's like saying 28 grams hydrogen plus 3 times 2 is 6. So in total 6 grams, because each hydrogen is 1 gram, 6 grams of hydrogen. That's going to give you equals 3 plus 14 from nitrogen. It's 17 times 2, 34. See what I mean? Once again, nitrogen is 17. I'm sorry, 14 plus 3 from hydrogen, 17 times 2, right? 34 grams. But that is not important at this moment, that mass. Just this one, the two masses I am comparing because I gave you double data. Now, you construct this relationship. How are you going to do this construction? Because you get to work the following. You do the double conversion I said before. Let's try, first of all, with nitrogen. Let's move, first of all, from 15 grams of nitrogen to be converted into grams of hydrogen, according to the map, according to my balanced reaction. So let's take the first 15 grams. Let's do the analysis. I am going to do the first analysis. I'm going to use not the color percent. Let's see. 15 grams of nitrogen, right? Let's pass that. You open conversion factor. Conversion factors, I am opening my conversion factor. And let's see. Let's pass it to grams. It says, how many grams in 1 mole? 1 mole of nitrogen gas has specifically, right, 28 grams, right? 28 grams of nitrogen gas. Right? It says, yes, 14 times 2, 28 grams, 1 mole. Also, my chemical reaction is saying how many moles of nitrogen are related to how many moles of hydrogen, because I'm just working at this moment, trying to find the limiting reactant. So I copy in this part the one for the reaction. I put in the lowercase the number of moles my reaction says. My reaction says I have 1 mole. So 1 mole of nitrogen. And in the upper part, I have how many moles? Oh, it says 3 moles of hydrogen. Good. And after that, you continue with your conversions. And then you open another conversion factor because you must pass the moles of hydrogen, right? Okay, how many moles? It says 1 mole of hydrogen is going to be converted into how many moles of hydrogen? 1 mole of hydrogen has specifically 2 grams of hydrogen, right? Because it's in the gaseous form. So then you put equals, you do the calculation, and you're going to find a specific answer. You're going to see that 15 times 3, right, times 2, and that divided to 28, and that's it. So it's going to give you, see, 3.2 or 3.21. Try to use 3 decimals always in chemistry. So 214 grams of hydrogen, right? See what I did in this? I just passed the 15 grams I received as data to, right, to moles of nitrogen, then the nitrogen to moles of hydrogen, and the moles of hydrogen to grams. So I compare, in this case, this is what I had for 15 grams for the data, and 3.21 grams I obtained in this calculation. I must compare it to the data I received. The data I received, it says 15 grams of hydrogen. Do I have that? Do I have 3.21 in the data I gave you? Yes, Mr. Victor gave me 15 grams of hydrogen, so I calculated I only need 3.21. So this calculation is perfect. So then this is correct, and this is correct for to be used in this reaction, meaning that the nitrogen, so in question A, right? The limiting reactant is going to be specifically nitrogen, meaning that the excess reactant, to be precise, so the excess reactant equals, or is going to be the hydrogen for this exercise or for the data I just received. Now we are ready to calculate the question that's posed. How many grams of ammonia? How are you going to calculate how many grams of ammonia can be produced? Because you use the limiting reactant. You use the limiting reactant, this one. You're going to use the value I gave you for the limiting reactant. What is the value I gave you for the limiting reactant? The number of grams. So let's get started to work. 15 grams, right, of nitrogen are going to be, of nitrogen. And then you perform the calculation. 15 grams of nitrogen, and you open the conversion factor because I'm looking for ammonia. I am still in the part above of question A because it says how many grams of ammonia. So they're looking for this, grams of ammonia. So let's transform the limiting reactant to grams of ammonia in the reaction, or by using the reaction. How are you going to do that? You open the conversion factor, 15 grams of nitrogen, and you do again the series of conversions I did. So for example, we get started in here. I know that 1 mole of nitrogen gas, right, in the second part is all specifically what? Yes, 28 grams of nitrogen gas in 1 mole. If you do the calculation there, also my reaction says that 1 mole, right, 1 mole of nitrogen gas produces specifically 2 moles of NH3, right? If you continue with the conversions, you're going to see that then also at the end, you know that 1 mole of ammonia, I'm going to pass it to grams, of NH3 has a specific mass. If you add 14 plus 3, so 17 grams of ammonia. And then you're ready because it says 2 grams, right? As you can see, I just passed from grams to moles, from moles to moles of ammonia, and from moles of ammonia to grams of ammonia. And basically that's what the question was asking at the beginning of this exercise. So that basically equals, specifically equals to, if you multiply that, is 15 times 2 times 17, and all of that divided to 28. It's 18.214 grams of ammonia. So I just answered the first question. Now let's go to question B. Question B, it says specifically, if 8.52 grams of ammonia are actually formed, what is the percentage yield? You see, in previous question, I am going to enclose this. I just obtained this answer, which is the one I was looking for. I am supposed to get that theoretically speaking. But if it says in question B, if I only obtain 8.52 grams, then what is the percentage? Then obviously, so if you only obtained 8.52, then you are supposed to do the following conversion. You divide the actual yield divided to the theoretical yield, and all of that times 100, okay? Times 100%. Why is that? Because the actual yield is what you actually obtained by doing the experiment, and what you did in the upper part is just calculations, some mathematical calculations. So that's not taking into account if the compounds were pure or not and stuff like that. Something could happen during the experiment. So we'll just replace the values. The actual yield, it says if 8.52 are actually formed, so as actually obtained. So 8.52 grams of ammonia, right, are obtained, right? 6 grams of ammonia are obtained. And then you divide all of that, divided to what? To what you just obtained in the upper dot, 18 point, that's the theoretical yield, to 114 grams of NH3, right? And then all of that times 100%. So you're going to obtain a value, and basically that was it, my dears. So then you just do it equals 8.52 times 100 and divided to 18.214. Yeah, it says 46.77, or actually 78% to be precise. Okay, so that was it. I hope you got this part and stuff like that. So